Hi guys, so we'll be solving an O-level past paper question from the year 2014. This session is May-June. This is question number 5. In this question, we'll use trigonometry to find the length, angle and area. Let's get into it. The question says, the diagram shows a framework ABCD supporting a shop sign. The framework is fixed to a vertical wall AB with CD horizontal. AC is equal to 64 centimeters, CD is equal to 80 centimeters, angle BAC is 35, angle BCA is 90 and angle ACD is 125 degrees. The first part says calculate AB. How to find AB? AB is this length. Now there is an angle of 90 degrees over here, so the question becomes really simple. In this case you use the cos rule. So you do cos 35 degrees, that's the only other angle besides 90 that is given to us, is equal to the adjacent, which is AC, that is 64, over the hypotenuse, which is going to be AB. When you do this, this becomes AB is equal to 64 divided by cos 35. When you plug this into the calculator, AB comes out to be 78.1 centimeters. So you write your answer as 78.1 up to 3 significant figures. The next part says calculate AD. Let's see where AD is. AD is this length over here. Now when you have AC and you have CD and you have the angle between the two lengths, you can only use the cosine rule to find AD. So let's use that. So you do AD squared is equal to 64 squared plus 80 squared minus 2 times 64 times 80 times cos of 125 degrees. Okay, I'm going to shorten this for us. This becomes AD squared is equal to the root of 16369.4. This is what I got when I plug all of this into the calculator. Now I find the square root on both sides. When I find the square root on both sides, AD comes out to be 127.9 centimeters. So this is our answer, 128, up to 3 significant figures. Okay. The next part says calculate ADC. Angle ADC is this little angle that we have over here. How do we find this angle? Now since this angle and this length is given to us, and then maybe this angle and this length is also now given to us, we can use the sine rule. So how do we use the sine rule? It's very simple. You do sine 125 degrees over the length of AD found in the previous part, which was 127.9. I'm going to use the whole length instead of the rounded off numbers. This is equal to sine of angle ADC, the angle that we are looking for, over, let's see what the length of sine ADC is. Since ADC is this angle, the length in front of it is 64. So we write 64 over here. Now we cross multiply it. You do sine ADC is equal to sine 125 times 64 divided by 127.9. So let's see what we get when you plug all of this into the calculator. Sine ADC comes out to be 0.4099. When you apply the inverse of the sine, the angle ADC comes out to be 24.2 degrees. So you write your answer over here, 24.2 degrees. The next part says, on the sine CDEF, FE is parallel to CD and is 40 centimeters below it. FE is 65. Okay, let's see. So first of all, let me remove all these marks for our understanding. So they're saying that this and this is parallel to each other. They also mentioned that these two have a distance between them of 40 degrees. Oh, sorry, 40 centimeters. This is very simple. They're asking us to calculate the area of the sine. This is the sine. We need to find the area of the trapezium or the trapezoid. How do we find the area of this? So you do half times the height, which is 40, times the sum of parallel sides. Now the two parallel sides were 65 and 80. When you solve this, the area of the entire shape, that is CDEF, comes out to be 2900 centimeters squared. And that's our final answer. You write 2900 over here and we are done with the question. I hope this question made sense. The complete working of the entire question is present in the description below for you to download. If you like this video, hit the subscribe button and thank you so much for watching.